ito. Then, paki-approve. Okay, so today ang pag-usapan natin ay yung sagot sa experiment 3. Na-checkan ko na lahat ng mga circuits ninyo, as you know. And ang hindi ko na lang, of course, ang na-checkan ay yung sa exercises o yung questions. So except for one group, so yung isang grupo lang yung na-checkan ko. Basically, yung first 7 questions ay huhugutin nyo lang naman from yung YouTube video na pinadala ko and yung previous na lesson natin sa tawag dito sa lecture sa 173. So frequency analysis series circuits, click nyo na itong file, nandiyan na yung kailangan nyo. Okay, to compute for the tawag dito, resonant frequency of the LRC circuit, quality factor, at saka yung bandwidth. Okay? And then to determine yung bandwidth, syempre ang gagawin nyo lang dun sa circuit o dun sa figure ay kukunin nyo lang yung minus 3 dB. Ang tawag dito, and then kunin nyo yung width between yung values ng frequency kung saan nag-intersect with the minus 3 dB na amplitude or na gain. Okay, so that should be easy enough. So let's go through yung discussion sa okay, so number 8. What is the effect of changing the resistance from 100 to 200 ohms on the bandwidth? Okay, so kung titignan nyo rito sa circuit, if you change the resistance, okay, from sa circuit, sa equation, sorry, by 100 times, so from 1 to 100 ohms, yung quality factor also decreases. And yung pag nag-decrease ang quality factor, yung bandwidth ay lalapad. Okay, so that should also be evident in the figure that you're supposed to include in your answer. And at least dun sa first group na na-checkan ko, yung sagot nila ay tama naman. Consistent yung lumabas na result na nakuha nila dun sa simulation with yung theoretical result. Okay, and then change the resistance, number 9, change the resistance back to 1 ohm, and then change the series resistance of the capacitor from 1 microohm to 0.1 ohm. Okay, so this series resistance is a leakage resistance. In other words, yung tawag dito, dielectric ay hindi nagwo-work properly, which means na hindi mataas yung resistance niya. So meron siyang finite resistance na hindi negligible. Yun yung model dito, or yun yung sinasabi ng series resistance dito. So how do we model yung series resistance na yun? Yung series resistance is modeled by adding a resistor in series with a capacitor. Okay, so here is how you model the series resistance. So kung titignan nyo, kung i-click natin tong sa capacitor, yung properties niya, at kung maghihintay tayo ng konti pa. So dito, ang series resistance niya is 1 times 10 to the minus 6 ohms. Okay? So, ang gawin muna natin is tanggalin natin muna ito. Disconnect natin itong series resistance. Okay? And then, i-comment out muna natin yan. Okay, and then i-connect natin ito. Okay, so this is your original na circuit, right? Okay, so tapos i-run natin yung corresponding na model linearizer niya. Okay, so if we do that, so kahit yung Bode plot na lang yung tignan natin. By the way, ang pronunciation pala nun ay Bode, para dun sa mga tawag dito, nag-uusap dun sa video at hindi malaman kung paano siya ibibigkas. The correct pronunciation is Bodhi. Okay. Okay. Okay, so ito yung result na ina-expect nyo for the RLC circuit. Itong graph dito, yung first two graphs ay yung amplitude tsaka phase graph when the voltage is taken across the resistor. And then yung third and fourth graphs ay yung amplitude at saka yung phase graph when the voltage is taken across the inductor at saka capacitor. So ang gagawin natin ngayon is papalitan natin ito. Okay, to 0.1. So gagawin natin itong 1 times 10 to the minus 1, apply. Okay, and click OK. And then i-run natin ulit ito to see yung effect. Okay, and then naka-superimpose, of course. Okay. Hintay na lang tayong konti. Next week, Thursday, ay simula ng inyong reading break. So, of course, ina-encourage na huwag kayong magtrabaho sa mga time na yun. Which is why yung experiment ang deadline is after 3 weeks pa. So, yan ang result. So, yung bread curve ay yung result ng changing yung series resistance ng capacitor. Okay. Now, ang gagawin natin, if we replace this, okay, balik natin sa 1 times 10 to the minus 6. Okay, and then we replace this with the series resistance. Is this model equivalent to yung series resistance ng capacitor dito? Okay, so kasi ito yung sinasabi natin model, right? Okay, so i-run natin ulit yan and then excuse. Okay. Then tignan natin yung result. Okay, so makikita nyo na by modeling the series resistance of the capacitor as a resistor in series with this circuit, we get exactly the same result. So yung LIN-SYS2, which was yung binago natin yung properties ng capacitor, is exactly the same with LIN-SYS3, which is when dinagdag natin yung resistor with the tawag dito with the circuit on the LC series circuit. Okay, so that's how you verify or that's how you model yung series resistance na ito. And this is something that tawag dito I'm going to look for dun sa report ninyo. So it's not enough na tawag dito dinescribe nyo lang yung difference. Remember that you always have to apply kung ano yung natutunan nyo sa lecture. And ang sinasabi rito is sa properties ng capacitor, napalitan yung series resistance. So which means na is it the same as changing or just simply adding a resistor in series with the capacitor? And the answer is yes. So you are modeling actually yung error na yun. So in an actual experiment, okay, ang gagawin nyo is anong tawag dito? Makakakuha kayo ng result which is similar to yung result ng LIN-SYS2. Okay? Pagkatapos, of course, pag kinumpare niyo yan sa theory, ang makukuha nyo ay yung blue curve. Okay, so tatanungin nyo ngayon, bakit hindi pareho yung theoretical na blue curve with the experimental na red curve? And ang gagawin nyo para masagot na yung tanong na yun is it, isang hypothesis nyo of course is it because of the series resistance of the capacitor? So you model the series resistance by adding a resistor in series in this circuit. Okay, and when you run the program theoretically, makikita nyo na yung theoretical modeling, which is yung yellow curve dito, is exactly the same as yung experimental na result. Okay, so ganun yun sa actual na experiment. Okay, so yun yung magiging sagot sa number 9. So now I can close this. Okay, and close ko na rin yan. So, that's also, tawag dito. Oops, nangyari. Nope. Okay, sandali. Okay. So, yan yung, I mean, theoretically, pwede nyo gawin din ito. Kung ayaw nyo gawin sa Simscape, you can do this. So, you can replace, or you can add a resistor in series with the capacitive reactance. Okay, so from this theoretical circuit without the series resistor, okay, you change the equation to this, na kung saan yung ZRC is given by this equation. Okay, of course, yung ZRC, kung makikita nyo naman, but ZRL to. So this should be CRC. So yung ZRC is, makikita nyo rito is also a complex number. So this is a complex number added to a complex number. And this is of course a real number. And then, ganun din yung pagkuha ng phase. And if you run this in a script sa MATLAB, you should be able to get the same result. Across the inductor, ang gagawin nyo naman is ilalagay nyo yung part na ito, okay, yung part na yan, okay, dun sa numerator. Okay. Included doon yung series resistor. Okay. And yan din yung makukuha nyo. O yan yung makukuha nyo for the gain and for the phase. Okay, so you can try it out for yourself. Okay, so ito yung result. Mali pa ata yung nakalagay dito. I'll correct this bago ko isend sa inyo. Okay, so now let's go to number 10 question. So change the series resistance of the capacitor back to 1 microohm. Change the parallel conductance of the conductor from 1 nanosiemens to 0.1 Siemens. Okay, and ano yung magiging result? Okay, so you already will have this circuit here. Okay, and this should be 1 times 10 to the 9. Okay, so apply. Okay, so pwede kong i-comment out ito. Okay, so ang nangyayari lang dito is you have a inductor or yung current nyo passes through the inductor and to the capacitor. So this is commented out. So walang nangyayari dito. Okay, so if I run that, we should be able to get yung theoretical result. Okay, so okay, body. Okay, and while we're waiting for that, tignan natin yung theoretical equations naman na nandito. So yung gain theoretically is described by this expression. Okay, hindi pa included diyan yung modeling. Okay. So this is for the this expression is for the voltage gain across the resistor, and this is for the gain across the series inductor at capacitor. Okay, so of course we get the same result as before. So yung first two graph ay yung across the resistor, taken across the resistor, and then yung next two graphs ay taken across the series ng inductor at capacitor. Okay, so if we change yung capacitance series, asa na ba yan? Oops, mali. Inductance. Parallel conductance to 1 times 10 to the minus 1. So 0.1 per ohm or 0.1 Siemens. So this will be 10 ohms pag kinuha niyo yung reciprocal nung makukuha nating result dyan. Okay. So makukuha nating result ay okay. So experimentally, ito yung makukuha. Okay. Experimentally, yan ang makukuha ang result. Yung kulay pula. Okay. So ngayon, in an actual experiment, syempre, tatanungin niyo, bakit iba yung theory with nakuha dun sa experiment? Ano yung source of error? Ang isang magiging hypothesis nyo is that yung inductance ay merong parallel na conductance. Okay? So, you model that parallel conductance with a resistor. Okay? So, ang conductance of course ay reciprocal lang ng resistance. So, ibabalik natin ito ngayon. So, 1 times 10 to the minus 9. Okay, and then yung 0.1 na tawag dito, Siemens is equivalent to 10 ohms. So 1 over 0.1 is 10. So yan yung model natin ngayon to check whether itong experimental result is the same as the tawag dito, ay yung sagot o yung tamang sagot dun sa hypothesis kung bakit different yung theoretical sa experimental. Okay, so you can now run this. Okay, and we see that the yellow curve overlaps with the red curve exactly. So, kita natin na tama yung hypothesis na ginawa natin. The hypothesis was there's a series resistance with the inductance. Okay, so that's how you answer number 10. And you can also do it via live script or by script dun sa MATLAB. Okay, by replacing or by adding this term. Okay, so this includes yung series resistance na term, R series na nandito. Okay, this should be R series pala. Okay, anyway, palitan ko na yung bago isend sa inyo. Tapos, oops, hindi ko ata na-correct dito. So, i-correct ko rin yung mga yan. Okay. So anyway, when I send the corrections, pwede nyo i-work out dun sa script kung gusto niyo. Okay, so and then ito yung result na nakita rin natin dito. Okay? So, yun yung inyong experiment 3. Okay? Any questions at this point? Okay, so I hope hindi kayo ganong nahirapan. Siguro ang pinakamahirap na lang dyan ay yung paggamit ng MATLAB. Okay, so huwag kayong mag-alala, nasa experiment 3 na kayo. So 3 experiments na lang. Okay, yun lang. Ang last 3 experiments ay hindi mas matrabaho actually. Because we're going to work with transistors and amplifiers. So yun yung magiging complication. So just a few reminders before, or just one reminder actually before we go to experiment 4. Briefing lang experiment 4. So yung grouping, apparently mukhang may problema pa rin. So I'm going to remove the grouping altogether. So magtatrabaho pa rin yung iba sa inyo in groups, pero magsasubmit kayo individually. Okay, and ang tawag dito, the reason for submitting individually is yun yung tawag dito, confirmation na nag-agree kayo dun sa both of you agree dun sa submission. So dapat both submissions ay anong tawag dito, ay exactly the same. Okay, and of course mahirap checkan yon para sa isang teacher. Okay, buti na lang when I take a look at your assignments. Okay, so for example here, okay, okay, mag-alala, isang grupo pa lang na checkan ko. So isang grupo lang, grade lang ng isang grupo ang malalaman ninyo. Okay, and ganito yung makikita. Sana hindi nyo makita yung ano. Ay, nakita nyo na. Ay, sorry, mali. So ganito yung makikita. Yan. Yan. Ito. So for example, ito si Vince at saka si JD, okay? Nakikita dito, dun sa Turnitin, may Turnitin kasi na feature yung ano, yung VLE. Makikita na 100% similar. Okay, kanino siya similar? So actually makikita na similar siya kay Vince. So malalaman ko using this Turnitin app na available sa VLE na pareho lang kayo ng work. Okay, so it's important na anong tawag dito? Na mag-submit kayo pareho as a confirmation na na pareho exactly the same kayo ng work. Na nag-agree kayo sa submission. So if I click this, okay, yan, lalabas yan, and ano na nga ito palabasin? Dito. Okay, and then malalaman ko kung kanino, yan, kanino siya pareho. Okay, if I click that. So, maganda rin siguro na pinapakita ko sa inyo ito kasi if your other teachers are using VLE and are using this Turnitin option, makikita kung nagkopyahan kayo o hindi. So makikita dito, ayan, lumabas kanina dito ang submission ay kay JD. Ngayon, ang lumabas na submission ay kay Vince. Okay? Kasi sinasabi ng Turnitin na pareho kayo ng work ni Vince. Okay? So that's one way for us teachers to check your to check at least for 173 para malaman ko na pareho kayo ng submission. Ano yung physical implication ng number 10? So may tanong si Vince. Anong ibig mo sabihin sa physical implication? Vince, paki-turn on na lang yung mic mo tapos paki-sagot na lang yung tanong ko. Ano ibig mo sabihin sa physical interpretation? Sa mga experiments, usually kung ano ang nangyayari. Okay. Sa experiments, okay, ano ang nangyayari? Well, mas malala pa dyan yung nangyayari. It could be a combination of both. Na leak from, anong tawag dito? From capacitor. So meron kang series resistance dun sa capacitor. Meron ka ring nasa na yun? Ay, kinlose ko na pala. Meron ka ring parallel conductance mula dun sa inductor. So makikita nyo pag nag-combine yung result ng dalawa na yon, tawag dito, medyo lalayo siya talaga dun sa theoretical na result. Pwede din na, of course, yung resistor na ito ay may tolerance na plus or minus 5%. You can still add that dun sa part ng error. At pwede rin na yung mismong power supply ninyo ay hindi nagpo-provide ng exact na voltage or exact na current. So which means na iba rin yung ano dito. Magiging output across the resistor at saka across the L at saka C na components. Ang isang malaking problema actually is yung grounding. Okay, so when you do these kinds of experiments, makakita rin kayo ng maraming noise. And if you're working with frequencies na malapit sa 60 Hz, makikita nyo yung effect ng 60 Hz na yon. Okay, pero anong tawag dito? In actual experiments, pinapascan naman yan from low frequency to high frequency. So meron kayong frequency generator, kayo na magsascan from 100 Hz hanggang sa 1 kilohertz o 10 kilohertz. Okay, titignan niyo yung result nung experimental result doon sa experiment. Okay, so at lower frequencies, kitang-kita niyo yung effect nung 60 Hz kasi parang magpi-peak siya or meron siyang konting vibrations. So hindi siya flat na katulad dito. Okay, meron pala ako nito. So hindi siya flat na katulad dito. Okay. Of course sa experiment, hindi niyo naman makikita yan na logarithmic yung scale. Okay? Ang makikita niyo is linear pa rin yung scale. So parang makikita niyo pag aakit siyang ganyan and then tataas na ganun, tapos bababang ganyan. So in linear scale, medyo flat siya dun sa low frequencies. And pag may 60 Hz, medyo tataas siya ng konti dito. So may low frequency sa 60 Hz, pababa siyang ganyan and then tataas dun sa resonant frequency and then bababa ulit na ganyan. Yun yung makikita niyo sa experimental
It's
result
11
na hindi
o'clock.
naka-logarithmic scale. Okay? So, yun. So, marami actually so marami actually tawag dito implication or marami kayong makikitang results na nagsusuperimpose pag sa actual na experiment. Okay? So, yun yung ano. Okay, any other question? Okay, so let's move on to experiment 4. So, ang sinasabi ko rito sa experiment 4 is merong 3 parts kung hindi nyo pa nakikita. So, ang first part ng experiment ay ito, AC source without a coupling capacitor. Okay? So basically, ang gagawin nyo sa experiment 4 is to understand the effect of the coupling and the bypass capacitor. Kasi nakita ko na ito yung parang isa sa mga weakness ninyo dun sa lecture part. So naisip ko na mas magandang mag-focus tayo dito sa effect ng coupling at saka bypass capacitor. So dito, yung first part is just a simple AC source tapos nakakonect siya sa isang resistor, sa isang load. Yung load dito is 470 ohms. And ang gagawin nyo lang is measure nyo lang yung current and then yung voltage across, current through, and then yung voltage across the load. And then may mga questions na nandiyan dyan. Okay, and then ang susunod is dadagdag nyo yung coupling capacitor at sasagutin nyo lang yung tanong, what is the effect of the coupling capacitor? So yan yung first part. The second part, voltage divider circuit naman. Okay, bakit voltage divider? Kasi ito yung magpa-power dun sa transistor circuit niyo. So ngayon, titignan niyo yung voltage divider circuit. Okay? May-measure niyo yung current through the load and then yung voltage across the load. Okay? So, ano na rin to, a small experiment na rin to regarding sa voltage divider. And then ang next part, kung titignan niyo rito sa baba, is idadagdag niyo na ngayon yung source. Okay, yung source ay directly nakakonect dito sa point na ito, okay, which is directly nakakonect dun sa load. Okay, so remember, hindi dalawang, in other words, the load ngayon ay nakakita ng dalawang sources. Yung voltage divider, which is yung DC component, and yung AC, yung AC source. Okay, so may DC tsaka may AC. Ang tanong ngayon is kung anong nakikita ngayon ng ammeter at saka ng voltmeter. So ano ngayon yung current through the load at saka yung voltage through the load. Okay, and then papalitan nyo ngayon yung, and then titignan nyo rito sa third circuit kung ano yung effect ng load, tawag dito, load resistance. Okay? Then dun sa third part ng experiment, ito na yung single stage na amplifier na gagamitin nyo yung circuit. Okay, now, wag niyong kalimutan ito, change the transistor settings. When you use the transistor, change the forward current transfer ratio to 125. So this is the DC gain. Okay? Iba pa yung AC gain. Mamaya pag makikita niyo kung paano yung i-obtain yung AC gain dyan. So ito lang papalitan niyo, yung forward current transfer ratio, which is the DC gain. Base emitter voltage VBE to 0.7. Ang default is 0.6. Ang default nito is 100. And then yung current IB for voltage VBE, so itong buo, yan, isang feed lang yan, papalitan niyo to 2.5 microamperes. Okay, so once na mapalitan nyo na yan, pwede nyo nang i-run yung circuit niyo kung na-setup nyo na ng maayos. Okay? So pansinin nyo rin na hindi na ako naglagay ng voltage at current sensors kasi ang instructions ay to measure yung voltage tsaka currents AC and DC across each of these tawag dito, across certain components. Okay, now para hindi kayo ganong mahirapan, ang isang posibleng makita nyo dyan is na result is meron kayong parang graph na na umaakyat. Okay, so dito na ako magdo-drawing. Dali. Okay. So ang isang makikita niyong result is pwede kayong makakita ng ganito. Okay? By the way, ang sinabi ko rito is 5 cycles. You may also need to increase it to 500 cycles. Okay? So, kasi baka pag 5 cycles, yun dito lang yung makikita nyo. So, kailangan yung i-increase to 5 cycles. Okay? In an actual experiment, hindi nyo na actually nakikita yan. Hindi nyo na nakikita tong part na ito. Yan. Ang nakikita nyo na lang ay yung flat na portion. Okay, so yan. So ano ang tawag dito? Ito yung posible isa yung makita sa experiment. It may seem na tawag dito DC lang siya. So ang gagawin niyo diyan is i-zoom niyo yan. Okay, so mag-zoom kayo sa region na ito, zoom niyo yan. Okay, i-zoom niyo i-zoom yan hanggang sa makakita kayo ng ang makikita niyo yung result is so pag naka-zoom na to, no? So pag nag-zoom na yan, okay, kunwari naka-zoom na. Yan, okay. So pag nag-zoom, ang makikita niyo ay ganyan. Well, hindi ganyan kapangit, mas maganda pa diyan. Okay? So, ano yung signal na nakikita niyo? Ang signal na nakikita niyo ay yung DC component and yung AC component. Okay? Now, walang linya diyan na katulad ng dinrawing ko dito. Wala kayong makikitang linya. So you have to estimate, okay? Really make a good estimation nung tawag dito nung parang DC component niya. And you also have to estimate itong peak to peak or kung gusto niyo ng peak lang, okay? Yung peak lang na yan, okay? To get the AC component. Okay, so that's two signals, a DC and an AC component, one on top of the other, superimposed. Okay, so kailangan yung ano yan, kailangan yung magawa yan. Well, kailangan yung maintindihan na ito yung dapat yung gawin. Okay, so medyo magiging matrabaho ito in this sense. Okay, and tulad ng sinabi ko, you have to work at around 500 cycles. So ibig sabihin 500 time constants. So if you ano dito? So ito, kung 1 kilohertz yan, of course from 1 kilohertz makukuha nyo na yung time constant, di ba? So pag nakuha nyo na yung time constant, you have to work at around 500 time constant. Kung saan flat, nadudun kayo sa region na flat. Okay? So I hope na clear yon para sa inyo. Okay, yun yung pinaka tawag dito, complication, pinakamahirap na i-achieve or result na pinakamahirap i-extract sa mga graph na yun. Okay, so other than that, just follow the instructions. Yung questions ay naka-embed na rin dun sa instructions para hindi kayo malito. And then you submit 3 circuits. So submit nyo yung itong circuit na ito, itong final circuit dito, and then yung final circuit din dito with the capacitor. Okay, so yun yung tatlong isa-submit niyo. Okay, nakalagay na mga instructions dito sa questions. Okay, so nakalagay din kung anong name ng circuit na ilalagay nyo. Okay, so nandiyan lahat yan. Okay. Okay, and yeah, I hope it's super clear kung ano yung tawag dito, kung ano yung isa-submit niyo. So, dahil medyo matrabaho ito, ginawa kong 15 points yung submission nyo ng Simulink, and then 15 points din yung submission nyo ng report. Okay, dahil about 12 questions yun. So, medyo marami rin yung kailangan yung sagutan. Okay, so that will be experiment 4. Okay, so tingnan muna natin kung anong, hindi ko pa natatapos yung sa experiment 5, so hindi ko alam kung paano grade distribution doon. Okay. So, any questions? Okay. Okay, any questions? Wala? Okay, so bago dumating yung karamihan sa inyo, may concern yung isa niyong kaklase regarding sa thesis. So, okay, hindi na to related sa 173. So, pwede ko nang i-stop.